All right. So we will look at bow work together. I'm going to switch to a screen with just problem 1 on it. And it says, write the rule for the inverse of y equals 5 to the x. Write the rule for the inverse of y equals 5 to the x. So what do we think when we see inverse? Flip the x and y. Yeah, we have the inverse rule y equals 5 to the x. And we know our first step is we want to switch the places of x and y. So we have x equals 5 to the y. And what's my next step? I've switched x and y. Switched x and y. What's my next step? Square it. What am I solving for? Right now it says x equals, but yeah, we want to solve for y. When we switch x and y, our next step is to solve for y. So what form is this in right now? What form is this in? It's an exponential form, exactly. And what did we say is the inverse of exponential form? The inverse of exponential form. It's what we've been talking about all unit. Yeah, it's our logarithmic form. So I'm going to make a note to myself that the inverse of exponential form is logarithmic form. I know the problem isn't asking that, but that's a good thing to remind myself. So I want to switch from exponential form to logarithmic form. What tool do we have when we're switching from exponential to logarithmic? What shape do we have to help us? The triangle, yeah. I can draw my triangle. So I want to put x equals 5 to the y into my triangle. What did I put on that bottom there? What's my base? Yeah, 5. And then I know that my left side of the triangle is my exponent side. That's being raised to the power, so you're right, Chris. It's y. And then what's the third value that I haven't used yet? X. And that goes in that third side, that third corner. So I have it in exponential form. I know I want to get it into logarithmic form. I want to solve for y. So I want it to look like that, y equals. Where do I look? Where do I look on my triangle for log? Where on my triangle is the log?
On the side of the 5.
On the side of the 5, exactly. I can put it right there. And I know that I'm going all the way across. So, I know I'm solving for y. I have a log. And my first number, my base, is 5. Because I'm reading the bottom side. And the second value I see, when I keep moving across the bottom of the triangle, is x. So the rule for the inverse of y equals 5x is y equals log base 5 of x. Now it asks us to find the domain and range of our original function. What does our domain represent? What are we talking about when we say domain? Yeah, our x's. Exactly. So our x values for y equals 5 to the x, what would that be? What can I put in for x? Can I put positive numbers in for x? Yeah. Can I put negative numbers in for x? Can I have negative exponents? Yeah, I can have negative exponents. I would just flip them to make them positive. So I can put negative numbers in for x. If I can put any negative number and any positive number in for x, how would I write my domain? Negative infinity to positive infinity. Exactly. So if my domain is my x values, my range is my y values. What y values will I get? 0 to infinity. Yeah, how do you know? Okay. What are you thinking?
I really forgot, like something 0.
Yeah, so there's something about the equation that we know. And we know that no matter what we put in for x, if we keep getting bigger for x, our exponent, our y, is just going to keep getting bigger too. That's the part where we're going to infinity. If I keep putting in negative numbers for my x values, that's going to keep giving me smaller and smaller fractions. So it'll never get to be a negative number for y. It'll just keep getting smaller and smaller to 0. Okay. So those are our domain and range of our original function, our exponential function. When we went from our original function to our inverse, we switched our x and y's. When we look at domain and range, those represent our x's and our y's. So if I know those two pieces of information, what would I do for my domain and range of inverse, my x and y of inverse? From my original function to my inverse function, I switched my x's and y's. What would I do with my domain and range that are x and y? I would just switch them. So my range would become my domain, 0 to infinity, and my domain would become my range. I switched my x and y here. I switched my x and y for these. Okay, I am going to move to the next screen to do number 2. And number 2 says to condense the following. So part A is natural log of 2 plus 4 times natural log of x minus 6 times natural log of y. What is that? What is my first step in my order for condensing? What is the first thing I look for? Exponents, that's a great guess. I am doing my power rule first. So, what do I look for It does say POW. It's short for power. If that helps you remember it, that's great. So what am I looking for in my expression to tell me if I need exponents?
Like, for example, ln, there's a number in front of it.
There's a number in front of my log. Exactly. There's something being multiplied to that log. So I know that my 4 will become an exponent and my 6 will become an exponent. Right now I don't need to do anything to natural log of 2 because I'm just looking at the exponents right now. And I'll bring down my addition sign. And I have natural log of x to the 4th minus natural log of y to the 6th. The number in front just moved into the argument, became an exponent. Now I've done my power rule. What is my second step in condensing? Product? Exactly. What do I look for to tell me that I have a product rule? What symbol? Yeah, I'm looking for addition. Looking for addition. And I know, because product means two things multiplied together, I know that I'm going to combine those by multiplying my arguments. So I will write natural log of 2 times x to the 4th. They're multiplied together. And we know our third step, the one we haven't done yet, is our quotient rule. What symbol am I looking for to know quotient rule? So it will become division, but I'm looking for my subtraction symbol. But yeah, that subtraction sign tells me that I'm going to want to divide that argument, 2 times x to the 4th, and the argument after the subtraction sign. So my quotient rule tells me I have 2x to the 4th divided by y to the 6th. Am I done condensing? Yeah. How can I check? I have 1 log. And what else do I only have 1 of? I only have 1 y, yeah. But what do I only have 1 argument. So I have 1 log and 1 argument. And that's how I know I'm fully condensed. All right, and in part B, we can do the same steps. We're looking for our power rule. Just like we said, we know we're looking for numbers in front of our log. So I have 3 and 2 in front of my log. And those will become exponents. So those will become my exponents when I rewrite it. Now, can I simplify that second expression just a little bit? Even before I go to product rule, I can rewrite that as log base 2 of x to the 3rd minus log base 2 of 9. Just to make it a little bit easier. Then once I do that, I'll look for my product rule. What am I looking for to tell me if I need product rule? What symbol? What sign? Addition. Do I see addition? No, but I do see subtraction. So there's no product rule here. But we still have to check for our quotient rule. And we said we did see subtraction. So our quotient rule for condensing tells us we're going to divide that first argument by the one after our subtraction sign. We have log base 2 of x cubed divided by 9. Are we fully condensed? Yes, that is fully condensed. We only have one log and one argument. All right, and I am going to move to the next page so we can do the problem 3. Remember, this will be up on Canvas later, or you can take a picture really quickly before I move on. So problem 3 says Talia and Miles bought toys from the same store. Talia spent $131 on 7 Hot Wheels and 8 Barbies. Ryan, we just introduced Ryan. Ryan spent $94 on 14 Hot Wheels and 2 Barbies. Find the cost of 1 Hot Wheels car and 1 Barbie. So this can be Ryan instead of Miles. Okay, what do we notice? Do we have any totals here? Yeah, what are our totals? 131 is a total. That's total for Talia. And 94 is a total. That can be a total for Ryan. So I know that I will have one equation that's equal to 131 and one equation that's equal to 94. Those are my 2 totals. What are we looking for? What are our variables? What are our variables? The Hot Wheels and the Barbies. What variables do you want to use for Hot Wheels and Barbies?
H and B.
H and B. That sounds good. Now, are we looking for the amount of Hot Wheels and Barbies? What is it asking us? Yeah, we're trying to find the cost or how much each one is. So our H is going to be the cost of a Hot Wheel, and B will be the cost of a Barbie. All right, what else does our problem tell us? Yeah, so our first one says 7 Hot Wheels and 8 Barbies. The other one says 14 Hot Wheels and 2 Barbies. How can I write that in my equation? I'm going to write 7 Hot Wheels, 7H, plus 8 Barbies.
And 2 Barbies.
Yeah, and then the next one will have 2 Barbies, 14H plus 2B, 2 Barbies. What method can we use to solve this? We have 2 linear equations. That's a system of equations. What method can we use to solve that? What method can we use to solve that? We have graphing, substitution, or linear combination.
Linear combination.
Linear combination? Okay, I like that. I already have them lined up. I have h's, b's, and a constant on the other side. What would I need to do to eliminate one of my variables? Do either of them eliminate right now if I added them together? No. So what would I need to do? Okay. Why am I multiplying the bottom equation by -4? Yeah, so what we're looking at is we have 8b and 2b. If we multiply the whole thing by -4, those b's will cancel out. So I can rewrite this as, my first one is 7h plus 8b equals 131. My second one, I have -4 times 14. What is -4 times 14? -4 times 14. I think it'll be maybe -56h. Is that right? Okay. And I have -4 times 2b. I have -8b equals, and then 4 times -4 times 94. What's that? -52? -4 times 94. -4 times 94. Okay, one more time. 376. Is that what everyone else got? -376. All right. So we will add those together. 7h minus 56h should be -49h. 8b and -8b cancel out just like we wanted them to. We have 131 minus 376. What do we get for that one? 131 minus 376. That needs to be that one. -245. And when we divide both sides by -49, we should get that h, the cost of a Hot Wheel, is $5. Am I finished now that I have 5? No, what do I need to do now? Put it back in. Which equation do we want to use? Top or bottom? Top. Great, we can use either one. I will now put 5 in for h. Plus 8b equals 131. I know 7 times 5 is 35. 8b equals 131. 131 minus 35. Give me 96. And 96 divided by 8 12. So I know that a cost of a Hot Wheel is $5 and the cost of one Barbie is $12. Okay. We are going to move on and look at our practice test. Looks like number 2. We're starting with number 2. Okay, let's see. 2. Okay. So number 2 says to expand each of the following. In our bell work today, we had some problems where we condensed, and we did our power rule, our product rule, and quotient rule. But we know that we do the opposite order for expansion. So our first step when we are expanding is our quotient rule. And when I'm expanding and doing my quotient rule, I look for division. So when I'm expanding, I look for division, and that will become subtraction. So the opposite way from our condensing. And we'll subtract the denominator. The denominator will become our argument. So we did our first step, our quotient rule. What's our second step? What's our order? Product is next. Because there's only 3 steps in each, it helps us out. We know that product is always going to be our second step. But product for expansion, for condensing, we looked for addition and then multiplied them together. When we're expanding, we look for that multiplication. So I see that 2 is being multiplied by x to the 4th. And I will expand that using addition. But nothing is being multiplied in that last term, that last part, log base 4 of y to the 5th, so I will just bring that down for now. And my last step when expanding is my power rule. That's where I write pow. And I see, I've got a couple exponents in my arguments. I have x to the 4th and y to the 5th. That first log I'll bring down because I don't need to do anything else to it.
Put it up, it's crazy.
Then I'll move my exponents to the front of the log. So I'm moving that 4 to the front of that log. I have 4 times log base 4 of x. And I'll do the same thing with that 5 in the exponent. I'll bring it to the front. And to check to make sure that's fully expanded, I look in my arguments and I say, do I have any division? No, I just have 2, x and y. Do I have any multiplication? Not in my arguments. And do I have any exponents? Not anymore. So that is fully expanded. And for part B, we'd do the same process, but we'd start by looking and noticing there's no division. So we wouldn't need to do anything for our quotient rule. And if you have questions about that one, we will have the key up on Canvas this afternoon, but it is the same process. Okay, we are going to look at number 7. Number 7. Thank you. So number 7, which is also similar to number 11, we have graphing a function y equals log base 3 of x. Okay, so the first step is to graph that original function. Oops. Y equals log base 3 of x. So when I'm graphing logs, sometimes it helps me if I can rewrite my log as an exponential rule so that it's a little bit easier. So if I rewrote that, I would have log base 3 of x equals y, which would be the same as 3 to the y equals x. So I know that I'm going to be putting my input in as y, and I would choose y to have those 5 values, the same ones we always use, and I would solve them to get x. So for -2, I would put 3 to the -2 equals x. I know when I have a negative exponent, I flip it to the bottom, and I have 1 over 3 squared equals x. So I know that my first x value will be 1/9. So I would graph my point 1/9 -2. And then I would just keep going. I would keep using my y values and plug them in to get x. So when y is -1, I would have 1 over 3 to the first. When y is 0, anything to the 0 power would give me 1. I have 1/3 -1 and 1 0. And when I put y equals 1, that's 3 to the first power equals 3. So my next point is the point 3, 1. And my last point for y would be 2. Or my last value for y would be 2. 3 squared is 9. So my final point is 9, 2. I would connect all of those points. So that's part A. Part A asks me to graph my log. Part B asks us to graph the function y equals log base 3 of x plus 4 plus 1. First thing I'm going to look for is my A. My A, my H, and my K. Do I see an A value? No, so my A value is just going to be 1, because 1 times anything is itself. Do I see an H value? Yeah, -4. It's the opposite number. Do I see a K value? My K is +1. So, to get my new X and my new Y, add h to my x, multiply my y by a, and add k. So I would have -4 plus 1/9 would give me -3.88. Y times a would be just y times 1. Plus k would be plus 1. So I have -2 times 1 is -2. Plus 1 would be -1. So I would have a point right around there. And I would keep doing that process for this one. And I would end up getting -3, 0. And just to quickly go through everything else, have 5, 3. And our line would look like this. Okay, hold on. What would be my vertical asymptote on this graph? My vertical asymptote, -4. Remember, you can use 1 page of notes, front and back, handwritten tomorrow. That does not mean your practice test, but we will have the review up on Canvas. Have a wonderful day. We'll see you tomorrow.